All right, so we're starting 10.5, so rationalizing denominators and numerators of radical expressions. So we're going to first start with rationalizing the denominator. And so when you're rationalizing the denominator, basically what you're trying to do is get rid of the radical in the denominator. And the way we do that is by making a fancy version of 1, using the value of the denominator in some form or fashion. For example, if I have the square root of 3 divided by the square root of 2, I'm going to focus on my denominator, and my denominator is the square root of 2. So what I'm going to do is I'm going to multiply the numerator and the denominator by square root of 2. And this equals 1, right? Because anything divided by itself is 1. So I'm not changing the value of this expression. I'm just changing how the expression will appear. So I end up with the square root of 3 times the square root of 2 divided by the square root of 2 times the square root of 2. Now we've talked about before how a radical times itself essentially sets itself free, because I'm basically saying I'm making a perfect square and then taking the square root of that perfect square. So that leaves me with the square root of 6 over 2. Ta-da! No more radical in the denominator. So we just rationalized our denominator. Alright, so what happens if your expression is a quotient? Or what happens if your expression has a variable in it? Well, same process. You want to make sure that you simplify your numerator and your denominator. And so we're going to separate our radical, and we have a square root of 2 divided by the square root of 45x. We're going to simplify the square root of 45x. First, we'll start by finding its factors and take the square root if it has a perfect square, which it does. So we have the square root of 9 is 3, and what's left inside of our radical is 5x. And now we're going to focus on that. So our radical, so 3 is already rationalized. It's normal to have just a number in the denominator, and that's part of our goal. So we're not going to multiply by the 3, we're going to multiply by the square root of 5x. So I'm going to multiply the numerator and the denominator times the square root of 5x. Well, 2 times 5x is 10x, and I have 3 times 5x, because I have the square root of 5x, then the square root of 5x is 5x. So I keep simplifying, and 3 times 5 is 15. And so, ta-da, there's my answer. Next, we are going to talk about what if you have a cube root. What does that mean? Well, it's a little bit different, because when we're talking about square roots, we want to have 2 of the same thing under the radical. When we're talking about cube root, we want to have 3 of the same thing under the radical. So we're going to separate them, and we're going to find the factors of 25, the prime factors of 25, which is 5 squared, because it's 5 times 5. Now, our goal is we need it to be the cube root of 5 cubed. That tells us that we are short 1 5. So instead of multiplying by the cube root of 5 squared, we're going to only multiply by the cube root of 5, because we only need 1 more 5. I'm going to multiply the numerator and the denominator by the cube root of 5. So when I do that, I end up with the cube root of 10 over 5. And we're done. So we're going to rationalize the denominator when there is a different variable in the numerator and in the denominator. Still separating. And once we separate, we're going to make sure they're in simplest forms, which they are, because 7 and 3 are prime numbers, and x and y are single variables. So from there, we're going to focus on our denominator. Our denominator is the square root of 3y, so we're going to multiply the numerator and denominator by the square root of 3y. I multiply, and I get the square root of 21xy divided by 3y. Boom. Now we're going to rationalize denominators having 2 terms. So I'm going to have 2 expressions being either added or subtracted together. When we have situations like this, we are going to use what's called the conjugate. Okay, so that means that if I am adding the two expressions, then I'm going to multiply by the two expressions being subtracted. For example, I have 3 divided by 2 plus the square root of 7. Well, notice how it's 2 plus the square root of 7. So its conjugate is 2 minus the square root of 7. I'm going to multiply numerator and denominator by that. I mean, put some parentheses there to emphasize that that is actually, well, they're actually together. So I have 2 plus the square root of 7 times 2 minus the square root of 7. If we remember our properties, if I have a plus b times a minus b, it equals a squared minus b squared. So that's our difference of two perfect squares property. And so what ends up happening is I'm going to simplify it, and I have 2 squared minus the square root of 7 squared, and that's because a is 2 and b is square root of 7. So I clean that up, and I get 2 squared becomes 4, and the square root of 7 squared becomes 7, because a square root times the square root of the same radicand sets the radicand free. And so 4 minus 7 is negative 3. Now if you notice, I have a 3 in the numerator and a 3 in the denominator. So that means that my 3 is going to cancel out. Be very careful when that 3 cancels out, because you are still left with that negative. So we're going to distribute that negative, and we get negative 2 plus the square root of 7 as our final answer. Good job. So let's go a little bit bigger. We have the square root of 3 plus 2 divided by the square root of 2 plus square root of 3. Remember, we're only focused on the denominator. So instead of adding square root of 2 and square root of 3, we're going to subtract. I'm going to multiply the numerator and the denominator by that. Okay. When we're multiplying our numerator, it's essentially we're going to treat it like we're multiplying two binomials. We're going to use FOIL. We're going to multiply first, outside, inside, last. So I have square root of 3 times square root of 2, which was my first. And then we have square root of 3 times negative square root of 3, which is my outside, plus 2 times square root of 2, which is my inside, and then minus 2 times the square root of 3, which was my last. So there's your FOIL right there. And then we're going to use the rule for difference of two perfect squares and simplify our denominator. So my a term here is, this is my a, square root of 2, and my b term is square root of 3. So it becomes square root of 2 squared minus square root of 3 squared. And so I keep simplifying. I simplify at the top by combining like terms, and my like terms would have been, well, my like terms are, so my first set of like terms are square root of 3, no, my only like terms are, I'm over here confusing myself. Never mind, I have no like terms. I'm going to simplify my radicals. So square root of 3 times square root of 2 is square root of 6. Square root of 3 times square root of 3 is 3. 2 times square root of 2 is already simplified. And negative 2 times square root of 3 is also already simplified. I'm going to simplify my denominator. And 2 minus 3 is negative 1, which means that my whole problem, so I'm going to move that negative to the numerator and then distribute that negative. So I distribute, and it became negative 6, positive 3, negative 2, positive 2. And this is my final answer. What about rationalizing the numerators? Rationalizing the numerator is not very good, but this is when you do not want any radicals in your numerator for some reason. So if you do not want radicals in your numerator, you're going to rationalize the numerator. So for example, if I had square root of 12 over 7 as an expression, I'm going to separate the expression into square root of 12 divided by square root of 7. My numerator this time is where I'm focused at, so I have square root of 12. So I'm going to multiply the numerator and the denominator by the square root of 12. That gives me the square root of 12 times the square root of 12 over square root of 7 times the square root of 12. I'm left with 12 over the square root of 84. The square root of 84 breaks down to become 4 times 21. 4 times 21, and 4 is a perfect square, so I'm left with the square root of 4 times the square root of 21, which gives me 12 divided by 2 times the square root of 21, which equals 6 divided by the square root of 21. So I could have simplified the square root of 12 in the beginning. So I could have made the decision to go ahead and say, okay, you know what? 12 simplifies down to 2 square root of 3. And then I would have multiplied square root of 3 all the way through. That could have been an option if I wanted it to be. And also would have gotten the job done as well. So I would challenge you to try simplifying the numerator using 2 square root of 3 and see what you get. Here's another example. We have a cube root of 9y divided by 7. We're going to separate them. And again, we're focused on the numerator, and our numerator is 9y. So we're going to break down this, and we end up with the cube root of 3y squared. Hopefully you know why, just in case you don't. Remember, when you're taking the cube root, you're trying to get 3 of the same number. So if I have 9 breaks down to 3 squared, which means I'm only 1 3 away from having my full group. And y is y to the 1, which means I'm 2 away from having my full group of 3. So I'm going to multiply the numerator and the denominator by the cube root of 3y squared divided by, well, I just said that, I'm sorry. Numerator and denominator should cover that. So I'm going to multiply. When I multiply, I end up with 9 times 3 is 27 y cubed. And then I have the cube root of 21 y squared. And the cube of 27 is 3. The cube of y cubed is y. And I can't do anything to my denominator, so I am done. Next example, we're going to rationalize the numerator again. This time we're going to have to use a conjugate, and the reason why we know we have to use a conjugate is because I'm adding within this expression. So I have the square root of x plus the square root of 7. So instead of adding them, I'm going to subtract. And I'm going to apply the numerator and the denominator by that. We're still using our difference of two squares property. Or we can just FOIL. And so when we FOIL, we have the square root of x times the square root of x makes x. So there's my f. And then I'm going to have the square root of x times the negative square root of y. And here's my o. Then I have the square root of y times the square root of x, which is my I. And then I have the square root of y times the square root of y is y, which is my L. And I'm going to FOIL also on the denominator. And when I FOIL on the denominator, the same process, very similar process takes place, except my signs are a little different. Once I've done all of that, I'm going to clean things up. I know that I have a negative and a positive of the same expression, so they're going to cancel out. So I'm left with, sorry, I simplified and didn't cancel yet. I'm ahead of my notes. I apologize. Now I'm going to cancel them out. And then I have 2 of the same, so I combine like terms. There's nothing else I can do, so therefore I am done. And that's my final answer. Can't do anything else to rationalize that numerator. And I don't need to because my radicals go